Alright, so again, last class we talked about if I have parallel lines and it gets cut by a transversal, then we have the following holds true. Corresponding alternate interior and alternate exterior angles are congruent. They're pairs. And then same side interior angles are supplementary. Now, again, we talked about how we have these special angles regardless of whether or not the lines are parallel, but when the lines are parallel, then we can say that they're congruent or supplementary. Today what we're looking at is the converse of each of these. And is the converse true or not? So let's take a look at on our notes. The first one says the converse of the corresponding angle is constant. It's kind of already started out for us. So two lines in a transversal form, but then plane. So let's take a look at my corresponding one. Corresponding angle is constant. If the transversal intersects two parallel lines, then the corresponding angles are congruent. Remember, converse, we flip-flop, right? We switch the hypothesis and conclusion. So what would be what's my conclusion of this? Go ahead.
They're congruent.
Yeah, corresponding angles are congruent. So that's now going to be my hypothesis. Okay, so let's go ahead and fill that in. So if two lines in a transversal form corresponding angles that are congruent, or congruent corresponding angles, however you want to phrase that, I'm just going to say congruent corresponding angles. Right, because that was my conclusion before. Corresponding angles are congruent. So now that's my hypothesis. If two lines in a transversal form corresponding angles that are congruent, then what? What do we think is going to be my new conclusion? Lucy?
The two lines are parallel.
Very good. Then the two lines are parallel. The two lines are parallel. And again, if I go back to my postulate over here, start off with parallel implies congruent corresponding. So we're flipping it. Corresponding congruent implies parallel. Oops. Alright, so the converse of the corresponding angles postulate says if two lines in transversal form congruent corresponding angles, then those two lines are parallel. So we start off by knowing that they're congruent, and then we can say parallel. We'll talk about whether or not this is true. Alright, I want you to now on your own go ahead and fill in 2, 3, and 4. Converse of alternate interior, converse of same side interior, and converse of alternate exterior. It's following that same format there. But use your postulates and theorems to help you kind of flip-flop your condition or your hypothesis and conclusions. Take a couple minutes to do that. As you're working through this, if you want to check with the person next to you, feel free to do so. Again, you're just following that same format. Looks like most of us are getting there, so give about 30 more seconds to finish this up. take a look at my original postulates and theorems here. What did we notice about the hypothesis of each of these conditionals? It's all the same thing. Remember, I copied and pasted. You guys rewrote it. But we have parallel lines, parallel lines, parallel lines, parallel lines. So if that was my hypothesis each time, that should become my new conclusion each time. So we should have seen as we wrote these out, my conclusion is going to be the same thing, then the two lines are parallel. Because that was my beginning hypothesis. I needed two lines parallel, transversal cutting dirt, to give me the ultimate interior angles are congruent. So now, two lines parallel is my conclusion. What's my hypothesis here? Good. Congruent alternate interior angles. For this one is here. Okay. Let's go and jump down to 4. Because it's pretty similar. What do we know about our alternate exterior angles if the lines were parallel? What would we know about them? They're congruent. So that was my conclusion. Now that's my hypothesis. Two lines in transversal form, congruent alternate exterior angles. Then the two lines are parallel. Okay. Now 3, it's same side interior angles. If I go back to my postulates and theorems from last class, if two lines are parallel, what did we know about our same side interior? Good. They were supplementary. So my conclusion was they were supplementary. So that can be my hypothesis now. So if two lines transversal form same side interior angles that are supplementary, we're supplementary same side interior angles. I'm going to use supplementary. Supplementary same side interior angles. Then what do we have?
Parallel lines.
Two lines are parallel. Alright, so we have each of these. The conclusion is that the two lines are parallel. Now, all 4 of these, we looked at the converse of them. And for all 4 of them, the converse is true. So now we can add to our bank that we have corresponding angles postulate, but also converse of corresponding angles postulate. Alternate interior angles theorem, the converse is also a theorem. Same side interior, its converse is also a theorem. Alternate exterior, its converse is also a theorem. Now notice that these 4 are to prove lines are parallel. Okay, so my converse of whichever case we're talking about is to show or prove lines parallel. Okay, so what we did last class was we were given the lines are parallel, then we can make those conclusions about special angles. Now, we don't know that the lines are parallel, but if I know those special angles have the properties of congruent or supplementary, then I can say the lines are parallel. Okay, so be very careful that you write the proper theorem or postulate. If you're showing parallel, you must have converse, and I will be very picky about this. Okay. Now, unfortunately, what this means is our title gets even longer, but it's just the way it is. So you have to write converse of alt int angles. Okay. But I do want to see that word converse right. Questions on what we've just done so far? Okay. So now take a look at your postulates and theorems page from last class. And so what we're focusing on today is this if-then chunk here. If two lines in a transversal form, congruent alternate interior angles, congruent alternate exterior angles, supplementary same side interior angles, or congruent corresponding angles, then the lines are parallel. I'll let you fill this in on your own time because we just wrote them on our notes. But this is, again, remember, the converse of each of those. Converse. I think I lost my email. Okay. So that's what we're focusing on today. Now you can kind of see a sneak peek of future lessons. We're going to be talking more about how to prove something about lines being parallel and perpendicular. But today we're focusing on, with my special angles, what do I need to have to show that lines are parallel. Alright, so let's just go and do some actual problems with this. So numbers 1 and 2 here, it says, is it possible to prove that lines P and Q are parallel? If so, explain how. Alright, so let's just go and take a look at this first one. As it stands, the 124 angle and the 56 angle, are they any type of special angle?
Oh, the ultimate. Oh, no. Yeah.
So let's go through the different ones. What's one of my special angles?
Ultimate exterior.
Corresponding, I heard an alternate interior. Good. Alternate interior, alternate exterior.
Same side interior.
Good. Same side interior.
What about same side exterior?
You know, that's not one that we have. That's not a classification we have. You'll probably recognize something about alternate or same side exterior ones. Yes?
I have a question for variations.
Mhm.
Can you also write SS?
No, I do need to see same side. I know. I thought about it, but didn't make the cut. Alright, so these are our 4 sets of special angles. Do those 2 angles have this relationship, any of these relationships? No, they don't. We see that one is outside, one is inside, but they're on different sides of it. The only one that's both inside and outside would be corresponding, but it has to be on the same side of your transversal. So we've got to do something more. What else can I say about this picture? What do I know? Come on. Oh, go ahead, Amani. It's okay. You both are like in my same line as I. Go ahead, Amani.
Okay. The linear pair of 124.
Do you want to go to the right or below? Okay.
No.
Over here.
Wait. The vertical angle.
Okay.
Yeah.
What is this going to be? Good. Do we agree that these are vertical angles and thus congruent? Yeah. Okay.
The next 124 adjacent to it, that would be 180 minus 124.
Say that again. 180.
180 minus 124, whatever that is, would be that little.
You mean this here be
Yes.
supplementary?
Yes.
Is that what you're saying? Okay. So good. We've got that we can say vertical angles here are congruent, or as on Kit said, we could say that these are supplementary. What would this end up being?
56.
56, yeah. Oh, gee, isn't that interesting? So using what we know from Unit 1, we could use vertical angles there to tell me that this is 124. Or I could use linear pair postulate with my definition supplementary angles and say that this is 56. So depending on which route you use might change then what theorem or postulate you would use next. So let's start off with taking a look at Amani's and then we'll take a look at our kids. So if I use 124, so we said linear pair postulate. Linear pair postulate. Now do I have one of these relationships? Which relationship do I have? Lucy?
Same side interior.
Same side interior. And same side interior needs to be supplementary. Are those supplementary?
Yeah.
Wait, that's not. Wait, that's not linear pair?
No. Oh, you're right. We're doing yours. Sorry. Vertical angles. We're going to come back to linear pair postulate. Okay, so this method, we had to first use vertical angles theorem, and then we say, hey, they're same side interior. And if those are supplementary, then I can say the lines are parallel. So if I use vertical angles theorem, then I can say the converse of same side interior or consecutive interior. So converse of same side interior angles theory. Then I can say that P and Q are parallel. Okay, so do you guys agree P and Q are parallel?
Yeah.
So yes, P is parallel to Q, and we use the vertical angles theorem and then converse of same side interior angles theorem. Now, let's go on Kitt's direction. If we would have instead said, hey, well, let's use the linear pair postulate. So now I have, these have some type of relationship. What relationship is that? Corresponding. So if I take the route, so yes, we're going to have P is relative. If I took the route of linear pair postulate, then that would actually give me a set of corresponding angles. We see those are congruent, so then we could use the converse of corresponding angles postulate. Because again, converse says, hey, I see that their measures are equal, which means they're congruent, so that must mean that they're parallel. Notice too that in my diagram here, there's no markings of parallel, because that's what we're trying to do. Alright, questions on that? Good job recognizing both of those guys. Now, again, if you would have done, maybe you might have done linear pairs this way, and you would have instead had alternate interior, right? So depending on which route you go, you would have it. Okay, let's take a look down at number 4 and 5. So here it says find the value of x that makes them parallel. So again, I am not given their parallel, but they want us to ensure they're parallel by giving the x value that will make sure that they're parallel. So again, let's first look and see. Does this currently have a special angle relationship?
Alternate exterior angles.
Good, alternate exterior angles. And what do alternate exterior angles need to be in order for those lines to be parallel? Go ahead.
Congruent.
Good, they need to be congruent. So I need these to be congruent in order for the lines to be parallel. So if they're congruent, what does that mean for their measures?
4x equals 4x.
Good, their measures are equal. So 4x equals 3x plus 30. This one's way too easy to solve. What do we get for x? So if x is 30 degrees, then that means those lines will be parallel. If x is 29, no such line. Alright, building chart number 5 there. Again, think of what relationship they have to let you know what they must be in order to make those lines parallel. Alright, what type of special angle relationship did we have? Good, same side interior. So what should be my equation that I'm setting up here?
3x plus 24 plus x equals 180.
Good, 3x plus 24 plus x equals 180. Do we agree with this?
Yes.
Okay, real quick, check your answer with someone nearby you, see if you got the same thing. Alright, bring it back up front. What did we get? 39, do you agree 39? Okay, let's take a look at the math for this. What do we get? 4x equals 156, is that what it was?
Yeah.
Okay, now remember, we're not using calculators, so we've got to think about how we can work smarter, not harder. Sure, you can do this off to the side, right? But we can do a little bit of mental math. How many times does 4 go into 15? And so that'd be 12, so we have then 3 left over. How many times is 4 going to 36? 39. Do that faster than it takes you to get out your calculator and punch it in. Alright. Now again, always be careful because they might ask you to actually go back and find the angle measures. Here though, just ask Rex. Alright, I want you to go ahead and do number 2 and check what you get with the person next to you. So the one right above.
Can you extend the other transversal?
Yeah.
Got a big fancy.
Oh yeah, that's a
If that helps you visualize it.
Sometimes when like it stops, like if there's a transversal like that, you can extend it and all this stuff.
Yeah, as long as you keep it the same. It sometimes might help you, sometimes it doesn't make any difference.
alright.
This is what
Single addition.
Alright, I'm hearing some good things out there. What do we need to do to help us arrive at our answer? Good. We've got to add these together. Now, when I add those together, what do I get? Oh, how nice is that? What did we use in adding those together? Angle addition postulate, right? We said that this angle is made up of those two added together. Why did I care for that angle? Good. It's corresponding with this one here. These are my parallel lines. This is the transversal. These are the corresponding angles. So we needed to use angle addition postulate to even know what that corresponding angle was. Okay. So do we agree that these are parallel or are they not? Yep.
I agree that they're.
I think they're parallel as well. So yes, P is parallel to Q. And we use angle addition postulate. We can say by angle addition postulate. And then what did we use? Converse of corresponding angles postulate. And converse of corresponding angles postulate. Yes, it's a long time. Alright, again, you have to be very careful to know the difference converse and yes.
Do you always use converse of, for the last one? Converse of?
It depends on what you're doing. Converse is showing that it's parallel. So since we're trying to show that they're parallel, we first had that they were the same, which means they're parallel. Okay, so if I'm going from measures equal or they're congruent, or if it's same second or supplementary, to show that it's parallel, that's always converse. If I start off, it's been given to me that it's parallel, and then I can make conclusions, that's going to be just the original. Other questions with this so far? Okay, let's take a look at the back side. Let's see. I want you to go ahead and scoot your desk together with your shoulder partner and do 7 through 11 on the back side.
Then the last
No way. It's like squared. Oh, I think it's like a thing
Yeah, you'll use your grouping, although this may be where you're going to find your numbers in your
+4x minus 9x
Guys, for number 10 here, that does say x squared minus 30. If you're having a hard time seeing that on your which ideally by now we're recognizing algebra coming back. What are we going to have to do? For number 10, factor.
I got you.
Like I said, factoring never goes away. It's here to stay.
I give up on that. Wait, 2 more minutes.
Nope.
We don't have to find the values of the angles.
No, it just said to find x. Yep.
Okay, we'll keep pausing.
Alright, 7, 8, and 9 should have been pretty quick and easy, straightforward. The 2 lines are cut by transversal, so that alternate interior angles are blank, then the lines are parallel. And great. Alright, number 8. The 2 lines are cut by transversal, so the consecutive interior angles are blank, then the lines parallel.
Supplementary. The supplementary.
Consecutive interior means? Same side interior, so supplementary. Alright, if 2 lines are cut by transversal so that blank angles are congruent and the lines are parallel. All of them. Good. This guy, this guy, and this guy. Good. Questions on 7 through 9? Okay. Let's take a look at these. Alright, number 10. What type of relationship are these angles? Good. So we need them to be congruent, which means measures equal. Good. Was it minus 3? Now, anytime you see that squared and the power of 1, that should hint to you factor, factor, factor. Alright, so I'm going to go and move everything to the left. So I've got x squared minus 5x minus 36 equals 0. Do we agree there?
Yes.
Alright, so we need 2 things, 2 factors that multiply up to negative 36 and add to negative 5. What 2 numbers accomplish that? Go ahead.
Negative 9 and 4.
Negative 9 and 4. Do we agree? Yeah. Okay, now, can I take the shortcut here? Yeah. Why am I allowed to take the shortcut? Yeah, it's a leading coefficient of 1. Then and only then can we jump straight to our factoring. If it's anything other than 1, we have to do the whole method, okay? Now, if you forget, that's fine. You're still going to get the same answer. You're just going to do 2 extra steps. All right, so we have then x minus 9x plus 4 equals 0. Do not lose that equals 0. We're solving here, not just factors. We're using factors to help us to solve. All right, what do I do from here? Go ahead, Mom.
You create 2 equations. One of them is x minus 9 equals 0, and the other one is x plus 4 equals 0.
Good, so I take each factor, set it equal to 0. Who can impress me and tell me why I'm allowed to do that? What is the name of it? You just look so excited. Go ahead. Good, zero product property. Well done. That's what you're going to say, right, Teresa?
Yeah.
Good. Zero product property.
I was so excited.
It's a book I like to call it. Alright, so zero product property, 2 things multiplied together equal to 0, at least on the past. Okay, so we have our potential answers of 9 and -4. But we're in geometry. Can I have negative angles? No. But be careful. Just because x is negative doesn't automatically mean we cut them out. We have to check it back with our situation. So first of all, if I take 9, put it in, will that give me a positive there?
Yes.
Positive here?
Yeah.
Yeah. Okay, so we can take that back. If I take -4 and put it in, do I get a positive here? No, it's a negative angle. We do not deal with negative angles in here. We cannot have a negative measure. When you get to pre-calc, you get to deal with negative angles there. But we're dealing with measuring angles, you can't have a negative angle. It just means a different direction. You just go in a different direction. There's the same starting point, and so positive goes this way, negative goes that way. You'll get to it.
Do you teach calc? Do you teach calc?
Calc this year. It's pre-calc. Okay, did we get 9? Good. And if we had both, we cross it out and 6 it to where it's just 1. Questions on that? So when x is 9, that is what will make these equal. That's what satisfies that equation, and then that means those will be pairs. Other questions on 10? Okay, now let's take a look at number 11. What type of relationship do I have here? Alternate exterior angles. Good. Alternate exterior angles. So what do I need to have for those guys? Good. Measures are equal. Now I look here and I see only x squared. No, just single x. I don't have to factor. You could factor if you really want to use the difference of squares. But it's going to be easier. Let's just get our x squareds together. And our numbers are equal. Good. Do we agree x squared is 49?
Yes.
Okay. Now when we square root, what do we get?
X equals positive or negative 7.
But then we're just going to take the positive.
No, we can't have negative.
You have to plug it back in.
But you can
square it.
Alright. So let's go through all that train of thought over there. You must have plus or minus. I'm still seeing us neglecting our plus or minus. You must have plus or minus when we're solving. Now, we need to check these. If I take positive 7 and put it back in, will I get an overall positive value?
Yes.
Here?
Yes.
Yes. If I take negative 7 and put it back in, will I get overall positive?
Yes.
Here?
Yes.
Yes. So here we are actually taking both values. There are 2 potential situations, 2 potential x's that will make those angles equal. One of them is probably going to be an acute, and one will be obtuse. Okay. No, not obtuse, but we have 2 different sets of angles that will make that parallel. It would just be a different slant of my parallel. Okay, questions on those 2? Now, as I'm going through and grading your test, which I'm still working on, I'm seeing that some of us have chosen to forget how to factor. Or rather, we're neglecting that we must factor by regrouping. We have to factor by regrouping in here. Now, the shortcut method is fine. That's technically factor by grouping. We just have a shortcut for it. But if we have a number in front, we cannot use a shortcut. You must know how to factor those. When you get to Algebra 2 and you have to factor 4 terms, the only method that works is factoring by regrouping. When you get to pre-calc and you have to factor sines and cosines, you're going to need to use regrouping. So we will do that in here. So somewhere on your paper where you have a little bit of space, let's go ahead and do one of those. Nope, I don't want that. I want a different one. Alright guys, write this problem down. Somewhere where you have a little bit of extra space. And we're just going to recap factoring real quick, because like I said, it doesn't go away. We have it all year long. Now, can I take the shortcut here? Do I have GCF? Nope. No GCF, so I can't get rid of that 2. No shortcut. So we've got to go back to good old-fashioned. What multiplies to my outside? Notice it's not just to negative 20, it's the outside coefficients. What multiplies to negative 40 and adds to negative 3. So what multiplies to negative 40 and adds to negative 3? Negative 8 and 5. Do we agree with this?
Yeah.
We're good? Is everyone on the same page? I see quite a few heads looking all around. Are we good? I want to make sure we're on the same page before this. Okay? So we just play the what's that factor game, and we're going to replace my middle term with this. Okay, so we still have 2x squared minus 8x plus 5x minus 20. Why am I allowed to suddenly pull a negative 8x out of 5x and wipe away those negative 3x and throw those in there?
Because it's the same value.
It's the same value. Negative 8x plus 5x is negative 3x. We're just rewriting it.
Oh.
So we need the 4 terms to factor, right? We needed to have 2 for GCF and the other 2 for GCF. So we split that up so that we can get our other terms. All right. What's the GCF of these first 2 terms? Let's just go with positive 2x. Don't call it negative unless that's the first one. And we're left with? Good. Always put a plus sign afterward. What can I factor out of these? 5. Shannon, you alright back there?
No, I'm getting bullied.
I have to. I can't really.
No, it's not me.
Oh, well that's Be nice. Do you have questions on this? You're good. You're clear. Questions on what we did so far? All right, insights match.
Yeah.
Yippee-ki-yay, they do. What?
I thought it was higher.
Yippee-ki-yay?
Higher.
Say, yodel woo. All right, and then what do I have left behind? 2x plus 5. Now, I could have said 2x plus 5 times x minus 4. That's fine. Why am I allowed to move these factors back? Commutative. Moving back. All right, questions on that? You're going to try one now on your own. And again, you must use the regrouping method. 12x squared plus 5x minus 3. Some of these things you guys are writing down are not equivalent and not acceptable. So some things that you guys are writing down are not equivalent, not mathematically acceptable. I'm going to leave this up here just so you can kind of see the pattern there, or the process. I was looking for my water bottle. Yeah, it's on my tablet. Once you get it, check your answers with the person next to you with your shoulder.
I would pass through that, but we just
Are we really looking for that?
it's Patrick the rapper. You know they tried.
Good. Alright, let's take a look at it. What was one of my factors? Do we agree with this?
Yes.
Do you agree with the plus? Okay. My other factor? I got 3x minus 1. Do we agree with that factor? Alright, real quick, let's go here, breaking it down. What multiplies to negative 36 that adds to 5?
Negative 9 minus 5. 4.
Positive 9x. What do I have to factor out here? Negative 1. Good.
It's plus 1.
Oh, thank you. Do my insights match now? Yeah. That's such a nice built-in check. Alright. Any questions on that? Okay. Before we continue, take a look at that assignment sheet. What's happening next class? Learn 2 lessons. Time for a quiz. Now, our quiz is on. Guys, listen up. Way too much talking happening. Put it away.
I'm writing my work down. Anybody
Okay, I'm watching you. Our quiz is on the first 2 days worth of material, right? So make sure we know the difference between when to use Converse and when not to. And you must have each piece of the time. Now, take out your classwork from last class. This guy. We started working on it for a wee little bit. We're not done. It's not focused. Alright. I know I switched you guys up and you started working on this. I want to talk about one of the problems on the back side. As promised, I did put the key up on Blackboard so you can check your work to see if you messed anything up. We did our proof. I want to take a look at this tree one down here. So that's a good real-world application problem. Now, I believe you had yours is written in, right? I think I wrote it in before I copied it. Yours isn't cut off.
Yeah.
Okay. So basically, we have a zip line connected to a pulley in the tree. They give us the measure of the angle here. They tell us this is angle 1, and I think they asked us for the measure of angle 1.
Yeah.
And what relationship are 1 and 115, right?
Alternate Q.
What that says. Okay. So let's go ahead. Again, anytime we have a picture like this, it's probably good to go ahead and extend out your lines. Also, whenever we're dealing with like trees or someone standing, we assume that it's perfectly perpendicular to the ground. I know that's not the case, and there's the whole curvature of the earth. But for our purposes, we're going to assume trees are straight up from the ground, that I'm standing straight up, and that's perpendicular to the ground. Okay, that comes into play later. So if these are both straight up and down, they're going to be parallel there. All right. Now, first of all, let's talk about the relationship. What's the relationship between angle 1 and this degree of 150? Good. Alternate interior angles. Now here they gave us a parallel situation. So what can I say about those alternate interior angles?
Equal.
They're congruent. So my measure of angle 1 is 150. Alright, questions on that? Now take a look back up here at 15. It says which solution for the figure at the right is, I think, incorrect. Asking that. Good. So we have two different situations here. I want you to identify which one's correct, which one's incorrect. Take a little bit to look at that.
What do you? Oh.
And then share with your shoulder partner.
Oh, incorrect.
I know. I think school thinks it's at 9:30. So I think the exact time has to be out there. It's the exact time. Alright, bring it back up front. Back up front, 3, 2, 1. Is the first one here right or wrong? Correct. So this one is incorrect. What was the mistake that was made?
Supposed to be.
Cameron.
So, the two angles.
Mhm.
So, the first on the right, he wrote the equation out like as if the angles were consecutive interior angles, but they're not. They're alternate interior angles, so they're
Good.
congruent.
Good. So these are alternate interior angles. And they gave us that these lines were parallel. So alternate interior angles have to be congruent, thus the left side. Good. Questions on that? Okay. Now, I want you to be very careful with your homework tonight. If you take a look at your homework sheet, what is your homework? Worksheet 2 and a textbook of one single textbook problem. So I highly recommend.
No question.
I highly recommend that on your homework you write 40 at the top, put a big circle around it so you don't forget to do it. Maybe start off by doing that problem when you do your homework so you don't neglect it.
Her jacket is a transversal
Is there anyone that did not get the homework? It is a worksheet. There's just more to it than one page.
I do have one.